them for a beam. One displacement, one slope, another displacement, another slope. So 1, 2, 3, 4. Total of 4, total of 4 shape functions. And this will be cubic, reason because we want to capture the bending of the beam. So take note, for a bar you cannot capture the bending. The response of a bar is just a linear extension or compression, while for a beam you want to capture that rotation as well as the bending, which is why you have a cubic equation for your shape functions. Okay, so let's have some exercise. Try to solve for this stiffness matrix here using this one here. So you have all these equations. B is equal to that. Second derivative of your shape functions. Then you have BEI, BT dx. Let's see if you can come up. So this one integrate from 0 to L dx. So let's have this exercise. You'll definitely need some warming up with integration anyway, so let's start with this one. So here, take note, we haven't introduced any Jacobian here, very straightforward. And I'll explain the reason why there are different approaches in determining the stiffness matrix. So what you should achieve here will be that standard equation. Okay, so try to come up with, try to determine your stiffness matrix. Start by determining your B's. B1, B2, B3, B4. Start determining your strain displacement matrix. Start by determining B. B is equal to Tn1, second derivative with respect to x. You have this equation now. So take the derivative, second derivative of this shape function. So once you determine that, this will be a column vector. Transpose, this will be a row vector. So you will get a 4x4 matrix in the end. Try your best to participate. Come on. Okay, let's get you started. What is B1? What is your B1? So that's the second derivative of your first shape function N1. 6x all over L squared plus 6 all over L cubed. So that is now x squared. So this one is d dx of minus 6x all over L squared. Checking, yes. Plus this will be 6x squared L cubed. And this will be minus 6 all over L squared plus 12x L cubed. So that will get you started. That is B1. So determine B2, B3, B4.
跟上。做完那个用的对比一会儿过我要写多点快一点。下这一张 discuss。我有一个头绪要这样做吧，我需要来 refine。在做。一定要撒一些东西进去的。
basically 他们现在想只是找到一个 B 的 value 而已了，你还要找 E 跟 I 啊。
对，你 I 有给我做上个 lesson 的，你的 I 是 y integrate y square dA。
Y square dA。
你要把你的 dA 弄成 dx。
We're not talking anything about weak form here or anything, just straightly substitute, get your B, substitute it here, and then solve for your stiffness matrix. So I'm not talking about weak form or strong form here. I'm just talking about you guys taking the derivative, substituting it here, and then solve for that stiffness matrix. Straightforward, very straightforward. Take the second derivative of your shape function, put it here. So B, this stiffness matrix B here. Your stiffness matrix B there is equal to B1, B2, B3, B4. Yes? So once you have that, the integral, so your K integral 0 to L of that B EI, B transpose dx. So this one will be 0 to L, B1, B2, B3, B4, EI, which you can bring it out later. And then you have your transpose. Yes? Dx. So you multiply these two vectors or tensors to be able to get a 4x4 matrix. You can bring this one out later, it's a constant. EI is a constant, just bring it out. And then you integrate each of these terms from 0 to L. So the first step is really getting B1, B2, B3, B4. That's the first step. So did you get your B's already? So B2 is minus 4 all over L plus 6x all over L squared. That's my answer. B3 is 6 all over L squared minus 12x all over L cubed. And my B4 is equal to minus 2 all over L plus 6x all over L squared. So once you get those values, you can proceed with this one here. Solve for your stiffness matrix. So please try it. I'm sure it will be better than just copying.
equals to 这样子，这个是要写的。
对呀，这里 A equal
你要扫这个 L 进去，then 你可以 cancel out B。
but 你要不要 indicate 啊？你需要 indicate 给这个 B
你
one
要
的
扫你的 B1 的东西的那些 value 进去。
他做完之后，
哪一个东西啊？哪一个？你要先扫一个 L 进去，then 你可以 cancel 那些 common term 的问题。then 有 Q value 哦，再做那个 matrix。then 就先一个 4 by 4出来。这样的 right？ Is it row size column or column size? Row size column size. B1 35 B1 is
要红色的。
就应该你不是有这个符啊，应该有一个符号的 right？ then 你把这个 L 放进去这些里面去，then 你就可以 cancel out 一些你不要的东西，就会有一个另外一个。因为你一下你扫这个 L 进去，那个符号的 L， 你 cancel out 那个 L 可以那个 plus 一个东西。then 你 multiply 的时候有没有？
里面少 L 进去
会有那个地方。
这也是 EI。哎，这个错吗？哎，是 EI 啊，因为你要找它那个有一个那个 sorry 哦。
所以你要把 L 放进去那个 X value 吗？
就我觉得 L 上面是 X，所以
因为你
这个 remake 的其实我比较是 12L 2 by L，这里每个都是这样。
对，然后你会 realize 上可以 cancel 的 L，有些就变成
这边才 remake 的
也是一样的，你要上进去。
就不是很多 L，这个也不是一样啊。
绝对是有 duplicate，所以你等下就可以 cancel，因为你 multiply 你 expand 然后你可以会有一些 numerical value。
就说要这个从这个变这个从这个。
你少了 L 哦，这样这样
对哦，还是你会变成4 by 4
4 by 4呢？
啊，4 by 4，因为你看，
哦是5 by 5，4
Why is this a 4 by 4? This is a 4 by 1, and this is a 1 by 4. Multiply this, you have a 4 by 4.
对，
So this multiplied by that here, that with that here, that with that here, and so on.
那种 integrate
And then you integrate. So let's see what you get.
我不懂。
integrate 的才小。
因为你 integrate 就是你要丢东西进去吗？那你才上进去那个 matrix 吗？你上 matrix 上你
So
才
it's
你要
very standard. The one you'll be able to get here will be the standard equation that we
你
always
要
use.
想很多 alphabetical 的东西。
我先扫进去这里，然后 L 丢进去先，所以没有那个 integrate 的那个在那边。哎呀，我就
你看哪一个比较标准？
上那个 X with L 那个。我把 L 扫进去。对 ，after that 你再把这个搬进去，搬，你就有很多东西。
multiply 的名字。
我要 multiply。你的乱上了。
没有，我那所以对不对？
你继续做先啊，继续做，你大概你会知道你的那个会不会对还是错？哇，这个会不会multiply会要命？啊？一样。就是你要 expand 那个东西会死人的。
哦，这个要 expand，
每个都要死人。
然后加 expand 然后这个打这个，连这个打这个，连这个打这个，连这个等于这个。所以你会有 duplicate 吗？对吧？一张纸不够了。
我已经 expand 到第2、3次了。
好了，我们就夸张了。
你看，一张，这个是按照这个的 calculation， 这样子。
定一下，这个我看对不对？
好。周末还有一个，你必都是。
就是上去那个 L 手。
哦，该说的也说了。
全部都不见了。这个有 L 吗？这个12 L， 这个6 L。
对啊，我是直接 cancel 那个东西。但是它不是颜色哦，我直接我没有写这个 step， 我是直接 cancel。
这个很乱。I know， 就学老师的。直接 B1
So this is just one of the solutions. Like I'm saying, depending on the shape function, you will be able to get your stiffness matrix. Let's see if we get it right. Anybody who wants to attempt the first row, first column? This one here? Let's do it together. So is this correct? Check if this one is correct. Okay. So Alex, would like to continue? Okay.
因为你这个两个人在一起嘛，所以你可以 simplify 这个东西，然后你再进去会比较容易。
那个 L 进去。
呀，因为如果你这样的话，你会做很多事情，你要一个这样一个这样，你会迷失。So the better way is to 把这个这个搬了，然后你再做这个会比较好。
反正看个人的，因为是那个 X 关系哦，你会忘记去扫那个 X 比较大。
It's the same thing，就是你可能会 miss 掉。
就是有些人会他忘记，我是怕忘记以为。
Okay, what's your answer here?
12 over L cube.
Sorry?
12 over L cube.
So 12 all over
Then you bring
over.
Then you bring
Let's try to divide this one with L cube. 12. So what about the others? Anyways, just a simple integration now. You probably have the hang of it. Let's just have it here. So 12 all over L cube.
The next one 就是
integrate，它同时 integrate 的话，你是 x square 吗 ？x square
Yes, so here you have b1,
对
b2.
哦，笨蛋。
Integral of b1, b2 dx. So what's the value here? So using the same procedure, what do we have? Come on. So who's next to Alex? Okay. Okay, next to you. Choose. Choose one. Choose one. Okay, you're next. What's the value for the this one here?
Give me a second.
Okay, 1 second.
没有，它 integrate 完过后，你全部会有一个 common 的 denominator 啊？不是你
在过后全部会有 LQ 的，
over L
哦，
去
比较
你在过后 LQ 的跟真的吧。
全部会变 L Q。
那不过理论来说是我还是有个感觉。我还是拿不到球，但是我没有做，我有看，我不是上去，到底是L 风，现在我已经过不了那个 L 了。
我 90 over L square.
哦。
90 over L squared.
这个来，是一个一条路，一条路。
More?
稍微迷就没有。
Anybody who wants to challenge this one? Yes? 6 all over L squared. 6 all over L squared. 6 all over L squared. Anybody? Second the motion. Third the motion? The answer here is 6 all over L squared. Next. Choose. So who's next? You choose. Who's next?
Good.
Okay. You're good. Shanugan. Where are you? Yes. What's your answer? Okay. Right. It will also be a good exercise, integrating and so on. You will be doing a lot of this one in plates anyway, so it's a good thing to at least recall those mathematical procedures. Okay, so you want to redeem yourself? What's the answer?
Negative 12 over L.
So negative 12 all over LQ. So he's redeemed already?
What the negative side?
So this is negative.
Yes.
Okay, so negative 12 all over LQ. Okay, so any questions with this one now? Negative 12 all over LQ. Okay, first row, fourth column. one, Shanmugam. Done already? Fourth. Good. So the third one has been solved already. So look at the fourth column. First row, fourth column.
6 over L squared.
Okay. Shanmugam, is it correct? Anybody who would like to second? So, are you okay? 6 all over L squared, you're comfortable with that? Okay. So, what about this one here? Second row, second column.
Yeah, that's all.
This side here, this side. Second row, second column. Okay. Give chance, give chance. So what do we have for the second row, second column? This block here. Anybody? It will be symmetrical. B1, B2, B2, B1. So we just want to determine the values here and here. So it will be symmetrical. But yeah, in the meantime, this, 1, 2, 3, 4, 5, 6, 6 more. So what do we have here? Anybody here? 4 all over L. Anybody who got different answer? 4 all over L? Still no reply from this side. 4 all over L. Confirm? 4 all over L. Why do you use calculator for integration? Still none? Okay, let's move on to the next value. Come on, this one is also one way of checking if you still remember your integration. You'll definitely need it.
L square is L.
听起来有些问题。
什么？
刚才
然后再做好东西，不要再去。
6 over L square.
L squared. Yes? Anybody got different answers? Anybody who wants to confirm? So what can you get here? Okay, so I will take that that's already confirmed. What about this one here? B2, B4. Two all over L. So he says 2 all over L. What about you? Can you confirm it's 2 all over L? Okay, double confirm. Anybody?
2 over L.
Okay, good. Next. 3, row 3. This one. So we need 3 more. Come on, 3 more.
12 over L cube.
12 all over L cube. Okay. Who says no? DC. DC. Where's DC? Okay. Okay. So what do we have here? 12 all over L cube? Okay. Column 4, row 3.
-6 over L square. -6 over L square.
Negative 6 all over
L square.
L squared. Finally, shall we move on still? Give me one, come on. Yes, okay. Is that okay? And this will be, of course, symmetric. So, anybody who would like to confirm this one?
4 over L.
Okay. So, and this will be symmetric. Yeah. So your stiffness matrix will be symmetric. As we can see, we just started from this one. We need your strain displacement matrix. Your strain displacement matrix is a function of your shape function. So the beam will have a different shape function as compared to a bar. Because you need to capture those bending and rotation, we have a cubic equation. As for the bar, we just have a linear equation because it's just extending and compressing. While this beam here will have displacement along the transverse as well as that slope, which is the rotation. This one, if we go back a bit, so assuming that this one now is correct, you have now here K, and then you can now solve your F equal to K multiplied by U. So F and U are your displacement and forces, your boundary conditions. So once you have this one, after you analyze this and that, then your problem is already solved. But we're not just doing that. We're going to dig in deeper. How did you get this one in the first place? Okay, so that's why I wanted us to have an understanding So digging deeper, being more analyst than a user of finite element, we want to determine how did we even get that equation for K. You know that for a bar, this one is the volume integral of that B, E, dV. That is for a bar. So I'm trying to brainwash you to think of this equation. And then for a beam, we have that equation wherein we have 0 to L, BEI, BP, dV. So our example here is very straightforward because we only take the XY space. We didn't even go to mapping wherein we have the C1 and C2. I think we did that with bar already, right? So this one is very straightforward, this solution. We just come up with this assumption where this is your different shape functions. You get your strain displacement values, integrate, you get now your stiffness matrix. Very simple, very straightforward. But take note, we took it from the XY space, or the X1, X2. We didn't even go to the mapping C1, C2, if you can recall what we did with the bar. Okay, so step by step, the question now is we want to get this one here. So what we did first for the bar was we used the method of weighted residual, wherein we have your weak form plus the Galerkin method. Okay, so we were able to get this K equal to volume integral dE B transpose dV. So this is how we derive it. Another way of deriving this one is by using the principle of virtual or your PVD. So there are many ways of deriving this equation here. So why do we need this one? Because this one is a more powerful method. So anyway, this one is just one method, this one is another method. You'll both end up to be having this one. The only thing is that if you're going for beams or higher order elements, this one is limited. So this is just one method of deriving this one. This one is another method in deriving this one, which is a more powerful method. Okay, so let's try to move backwards and ask our question. How did we get to this one? So we had that already in your method of weighted residual as well as your Galerkin method. So let's proceed with the, I'd like to repeat this one maybe a bit faster, and let's discuss about the principle of virtual displacement. Why? Because you'll need this concept for your plate elements. By the way, if you're going to ask me what is the scope of the exam, yeah, everything. Elasticity, pressure vessels, finite element, 2D. Okay, so I think we have time to really complete the 2D finite elements. So we probably have another 2 weeks of revision or tutorial sessions. Okay, so I hope you had a good exercise in deriving the stiffness matrix. So our question now is, how do we get to this one? And we answered this one by using the method of weighted residual and the Galerkin method to come up with this one. Let's study the other method, principle of virtual displacement. So your PVD, yes? I have this one to be my stress strain. So Hopefully you're familiar with this one already. Yes? So you have your elastic, plastic. Elastic region, plastic region. For linear, elastic, finite elements, we only use the elastic region. Okay? Can we have a 10 minutes break for you just to stretch after the exercise? And I'll continue with this one.